Hello, my name is Evan Katsuyama. Today I'll be doing SLO1-1. I'll be doing problem 16 from my section 1.1 homework assignment. And the problem I'll be solving is estimating the area under the graph of f of x equals to 1 over x plus 3 over the closed interval of 2 to 7 using 10 approximating rectangles and the right endpoints. So I'll be looking for the left and right endpoints using left-hand Riemann sum and left-hand Riemann sum. Yeah, let's begin. Get it in. Good. That worked. There we go. Wait, is it? I can't tell. There we go. Just gonna touch it. Okay. So. Good. Very good. Okay. So we got our equation right here, the 1 over x plus 3 from the closed interval 2 to 7. And what we want to find is from the right hand, the endpoints, the right hand and the left hand side. Okay. So first, what we want to do is find the width between the rectangles, pretty much, which would be, to solve that, we want to use change of x equals to b minus a over n, which n is referring to the amount of rectangles, so we just put in a value, 7 minus 2 over 10 equals to 5 over 10, which equals to 1/2. So that is our width. And now what we could want to do now is find the right endpoint approximation, and we will use this equation. R equals to change of x, delta x, in other words, the sum of from I equals to 1 and to 10 of f of x I, which xi is referring to the sample point, and then where what's it called? So the sample point is equal to 2 plus I times 0.5, which 0.5 is referring to the what's it called? The width. And once we do that, we could let's just make a table for our convenience. It would be from I 1, 2, 3, 4, all the way down to 10. Then next one will be our sample point equation, which will be equal to 2 plus I guess you could say 0.5i, or you could do the same thing as this one here. It's the same thing. And then we want to do our values that we could put it, once you solve this, you could put it into our equation of here, or yeah, into this one here. And then, so that would be what, 1 over x plus 3. And then once we, okay, let's just put 2.5, because you just put in 1 times 0.5 plus 2, 2.5, so on and so forth, 3.5, 4, because 4 times 0.5 is 2, plus 2 is 4, and let's just go all the way down to 10, which would be 10 times, what's it called, 0.5, which is just 5 plus 2 is 7. And then let's see here, let's just put in here, which is what, 1 over 2.5 plus 3, which is 1 over 5.5, and then 3 plus 3, 1 over 6, 1 over 6.5, and then 4 plus 3, or 7, so 1 over 7, and so on and so forth, to let's go up to 10, because there's 10 points, or because there's 10 rectangles, And let's see, that would be 1 over 7 plus 3, which is 10, so 1 over 10. And then what we want to do is add everything up to find the sum. You just add everything up, which we would get about, it would be about, what was it? If you add everything up, which would be roughly about 1, where is it? So Rn, right endpoint approximation is equal to the change of x, or the width of the rectangles, which would be 0.5 times the sum of everything of the rectangles, which would be about, what was it, let's make it 1.3375, and this will give us an approximation of 0.6688. This is what we get for finding to find the right endpoint approximation. Now, what we want to do, since we got half of the problem solved, you want to solve for the left endpoint approximation. And to do this, you want to do pretty much the exact same thing here. However, our sample point equation will be slightly different, just very slightly. So left endpoint approximation equals to change of x to the sum of 10 to I equals to 1, and the f of x I. Okay. However, sample point is equal to 2 plus, the reason why it's 2, because that's like the starting point. That's why. Plus I, or the point from here, I minus 1, or I, times 0.5. 0.5 is the width of the rectangles. And let's do this. Let's pretty much do the same thing. Make our table. I 1, 2, 3, 4, all the way down to what is it, 10, and then let's do the same thing. Sample point equals to 2 plus where am I at? This equation, so it'll be I minus 1 times 0.5, and then the f of xi, which f of sample point, which would be 1 over x plus 3. And once we do that, we get 2, because 1 minus 1 is 0, so it'd just be 2, 2.5, 3, and 3.5, and all the way down to 10, which would be, what is it? 10 minus 1 is 9. 9 times 0.5 is 4.5 plus 2 equals 6.5. And then let's put into this equation. This one here, 1 over 2 plus 3, 1 over 5. 1 over 5.5. Then 1 over 6, 1 over 6.5, and then all the way to 10, which will be, what was it, 1 over 9.5. Yeah, oh, no, my bad. Yeah, I'm right now, not 1 over 9.5. Okay? We want to pretty much do the same thing from here. We did from the right endpoint approximation, which would be to do the left hand. You just, since we got our values, we just want to add all the sums up, which would be the left endpoint approximation is equal to the width of rectangles, which is 0.5. Okay, and then if you add everything up from 1 to 10 of this approximation, which will give us about what was it, times 1.4375, and then which will be about roughly 0.7188. And that's what we do.